Hi my beautiful friends on the YouTube. So today in this video we are going to cover the two sum interview question. This question is a very easy level question and a very classical technical interview question. So if you are starting for the DSA rounds or the technical interview rounds, then this question you will encounter at least once when you are starting. Okay, so let's check out the question, what this question says and what we have to output, and we will then also discuss the different approaches to solve this question. We'll go from brute force to the optimal one. Okay, so it is a two sum. Okay, two sum. Suppose we are receiving an array of integers like the 2, 7, 11 and 15, and along with the array we are also getting a target value, right? So in this case we in this example we are getting an array of integers like 2, 7, 11, 15, and the target value is 9. Okay, so what we have to return? We have to return two numbers indices which add, or we can say which add up to target. Okay, so that means we need two numbers from the input array such that their sum should be equal to target value. Okay, so you can obviously see that in our input array we are having those two numbers. If we add them together, we'll be getting our target value. Okay, so obviously this is 2 and this is 7. So if we do 2 plus 7, which will be equal to 9, and 9 is also our target. Okay, so that means the answer, the sum is equal to target. So then we have to return the indices of those two numbers. Now what are the indices? Okay, so from the array you can see that 2 is at the 0th index, 7 is at the first index, 11 is at the second index, and 15 is at the third index. Okay, so our final output will be 0 and 1. Okay, please remember that we are not returning the actual values which sum to the target value, but we are returning their indices. Okay, so this will be our final answer. I hope that you have understood the question properly. Now we'll see the first approach to solve this question. Okay, so approach 1, this is our input array, right? And we have target value, suppose t, target is 9. What we can do, we need to find out two numbers. Suppose this is our equation, target equal to value 1 plus value 2. Okay, so what we need to do, we need to find out the first value 1, then we need to find out the value 2, then we are going to sum them together, and then we'll be checking that sum against the target value. Correct? If that is matching to our target value, then we are done. We'll be immediately returning their indices. Okay, so what we can do, we can run a loop. Okay, we can run a loop one time. This loop will traverse every element present in our array. Okay, so using this one loop we'll be getting our value 1, and then again we can go ahead and have second loop. Okay, so the second loop will give us the value 2. So to get the two values, we are looping 2 times. Okay, we are running 2 loops. So this approach will work. Okay, so let's check out the code, and once we write down the code, then we will see what is the problem in this code. Okay, so suppose this is how the code will look like. This is our function. We'll be getting an array of integers and a target value. Okay, and then we'll have the first loop for getting our first value, or we can say value 1. Correct? So this is how our loop will work. Let I equal to 0, it will start from the 0th index. It will traverse all the element present in our array. Okay, and then for the simplicity I can store this in a variable constant first name. Okay, then inside that loop we can have a second loop. So the purpose for this second loop is to find out the second value. Okay, and this is how the second loop will work. Okay, so it will one step ahead of the first number, because we want two numbers on the different indices. Okay, we don't want them on the same indices, so the index will be different between two numbers. It will also traverse all the element. Okay, and I can also store this second number in variable. I'm sorry if my writing is not good, because I'm getting used to this thing, pen tab. Okay, anyway. Okay, now we have our both numbers, the first number and the second number, correct? Once we have that, what we'll do, we'll check their sum against the target value. Okay, I can write down condition. I can say if first num plus second num equal to target. If this case is true, then we are done. We are going to immediately return the indices I and j. Okay, so this if statement will end here, this inner for loop will end here, outer for loop will end here, and then at last our function will return null if those two numbers are not present, or if the sum is not equal to the target value. Suppose this is our input, right? 2, 7, 11, 15, and we have been given the target like the 100 or anything like the 200. Then we can obviously say that there are no two numbers. If we add them together, we will be getting that 100 or 200. Okay, so that is out of reach. So in that case, our function will return null. Correct? So this is how this code is working. What we are doing, we are running a loop to get the first number, then we are again running a loop to get the second number, and then we are checking the sum of the both numbers, like the first number and second number. We are checking that against the target value. If that is correct, then we are immediately returning their indices, right? Now the problem with this approach is the time complexity is order of n square, right? Why it is order of n square? Because we are running two loops, correct? The nested loops, and space complexity is order of 1. So this is the best space complexity that we can get, but this time complexity is bad. Okay, because we are iterating each and every element 2 times. Why 2 times? Because we needed 2 numbers, so that is why we are running loops, nested loops, 2 loops. So that is why it is a order of n square. Now to make this one better, we need this in the order of n. This should be the good time complexity. Okay, so this order of n square, the solution will work, right? Our solution is correct, it will work anyway, but the performance of our algorithm will be bad. So that is why, can we do better than this? Instead of order of n square, instead of 2 loops, can we do it in order of n in a single loop? Okay, so that is why the second approach comes into the picture. So approach 2. Okay, so as you know that we had this equation target equal to value 1, okay, value 1 plus value 2, right? So can I write down this equation like this? Target minus value 1 equal to value 2, correct? So what we can do, we can only run a single loop, we can get the value, we can subtract that value from the target, and the result we will be getting after that subtraction, we can check this in the past if we have seen this particular element or not. If we have seen that particular element, then yes, we are done. So those two numbers are present, and then we can return the indices, right? So see, the simple logic is we just need to have we just need to iterate one time. For each element we need to check, we need to subtract that from the target, and whatever we'll be getting, we need to check if that element is present in our in somewhere or not, if we have tracked that down or not. Okay, so for the better understanding, I can show you like this. So we have 2, 7, 11, 15, right? And target is 9. Okay, so and we can also have a hash table. Okay, hash table. So what is a hash table? Hash table is very useful if you want to check any element, or if you want to look back in the past, if to make sure that if we have tracked down that particular element or not. Okay, so it's like the history book. We can dig into the past and we can track down the element. Okay, and this is one benefit of hash table, and another one is we can also store the index in this. So it is like the key and value pair data structure, correct? So what we can do, we have target, and suppose our current element is 2. Okay, because we are running a loop. Okay, a single loop. For every current element we will minus that current element, and we'll check if this if this is present in the hash table or not. Okay, so is 7 present in our hash table? No, right? So what we'll do, we'll be adding this 2. We can say that this 2 is complement, right? So let's add this 2, and along with this 2 we are also going to add its index. Okay, so what is the index of 2? This is how the indexing is: 2, 1, 0, 1, 2 and 3. Okay, so the index of 2 is 0, correct? Now let's go ahead. Now our loop is at 7 at the first index. Now we'll check target minus 7, which will be equal to 2. Now we'll be going to check if 2 is present in a hash table. Yes, it is present. Okay, it is present in our hash table. So that means we have received our expected output. So what we'll do, we are going to output this. We'll be getting this one element's index. Okay, and the current element's index. Okay, so this is our final output. So this is how approach 2 works. Okay, it uses the hash table, and we are storing the element, and we are checking that if another element is present or not. Okay, so the code will be like this. Okay, we'll be getting an array and target, and we'll be initializing our hash table. Okay, so then we'll have a single loop for a value. Okay, this is how this loop will work. We'll start from the 0 and we'll go till the end. And here we can have our complement. Okay, our complement will be target minus the current value, right? And now we'll be check in the hash table for complement. Okay, so if there is complement present in our hash table, then yes, we are going to return the complement index and the current elements index, right? Here we are done. We have come up with the solution. This if will close here, this for loop will close here, and at last we are returning null value if the sum is not equal to target. Okay, so this is how this code will look like. Okay, now the time complexity of this algorithm is O of n. Okay, we have reduced it from the O of n square. In the approach 1 we were having O of n square, so instead of 2 loops we are now just using a single loop, and the space complexity is order of n, right? Now the reason is the space complexity is order of n as compared to order of 1, because in the approach 1 we had order of 1 space complexity, but in this approach the space complexity is order of n. It is because of the map or the hash table that we are using, because if the number of elements grows in the input array, then this map will also grow, right? It is not constant, so that is why space complexity is also order of n. Okay, so there is also another approach that I should tell you, but it is limited in the sense that it will work on only sorted array for the same question. Now this is our input array, right? 2, 7, 11, 15, and target is 9. You can see that our array is in the increasing in the ascending order. Like we have 2, then we have greater element than 2, 7, then we have greater element than 7, 11, we have greater element than 11, 15. So it is increasing, right? There are no random elements present, so that means it is sorted. Okay, it is sorted. So only for the sorted array this approach 3 will work, right? So what we can do in the approach 3, we can use the two pointer technique. Okay, we can have 2 pointers. Suppose our first pointer is L and the second pointer is R. First pointer is starting from the 0th index, and the R pointer, which is the right pointer, it is starting from the last element of our array. Okay, what we can do is we can check if their elements are equal to target or not. Now you can see that L, the left pointer's value is 2, okay, and the right pointer's value is 15. If we sum that together, we will be getting 17. But the 17 is greater than the target value. The target is 9. Okay, so in that case, if the target is 9 and the sum is greater than the target, what we can do is we can reduce this one step behind. Okay, we can move that one step behind. So now the R is at the 11. Okay, so instead of 15, I'll write down R is at 11. Okay. 11, and this sum will be 13. Now again, this 13 is greater than the target. 13 is greater than 9. Okay, so in this case we can also again will be moving behind this right pointer, correct? Now this R is at the 7. Okay, right pointer is at the 7 and their sum is also 9. So the sum is equal to target value. Okay, so this approach is also working. So finally we can just return the left and right. Okay, because that is the indices. So this approach will only work on the sorted array if your array is increasing and you have been asked the same question. Okay, just give me the code. So the code will be like this. So the function to sum, same we are getting array target, and we can initialize 2 pointers. 2 pointers, one is left, it will start from the 0th index, and one is right, it is starting from the last element of the array, correct? And then we'll have our while loop. We'll check till the left is less than right. We'll add the condition here. If array at left plus array at right, if their sum is greater than the target, if the sum is greater than target, then what we are going to do, we are going to reduce right pointer. Okay, else if, okay, so else if the if the array at left plus array at right, their sum is less than the target, then our left pointer will move one step ahead. And else if above both conditions do not satisfy. Like if our sum is neither greater than the target and neither less than the target, then yes, we have got our correct solution. Then we are going to return left pointer and the right pointer, right? So this is while loop will end. Okay, and at last we can return null value. Okay, so this is how this code will look like. So using this while loop means we are running just one loop, correct? So this is the solution, but remember, always remember, use these only on the sorted array. Okay, correct? And the time complexity of this solution is order of n, and the space complexity will be order of 1. Okay, so this solution is actually better than the second approach, but it is limited, correct? So if you have been getting the sorted array, then you 100% should go with this solution. Why? Because it is also giving us the better space complexity. In the approach 2, when we were using the hash table, this space complexity was order of n, but in this solution the space complexity is order of 1. Okay, so on the sorted array you must go for this 2-pointer technique approach. Okay, so thank you guys.